This is dividing complex numbers, but we're really not dividing them. What we want to do is turn this denominator into a rational number. We're really rationalizing. So the same rule is going to apply. We have to use the conjugate. Just like with multiplying, we already found that if we multiply by the conjugate here, that the middle terms, the middle two, the imaginary parts, will get canceled off. 6 minus 6, 12 minus 12, because we're getting the plus and the minus. So, the conjugate of 3 plus 2i would be 3 minus 2i. And for negative 3 minus I, it would be negative 3 plus I. So all we're doing is turning the plus into a minus and the minus into a plus. So what would the conjugate of 2 minus 3i be? It'd be 2 plus 3i. And that's what we're going to multiply by. So we have 3 over 2 minus 3i. And we're going to multiply top and bottom by its conjugate. So let's do that. So we're going to multiply the bottom. We have to use FOIL, which gives us 4, 6i, minus 6i, and minus 9i squared, which we know is just 9, because the I squared becomes negative 1 and changes that sign. And then these cancel. So what we could have done is this instead. 2 times 2 is 4, and then minus 3 times 3 is minus 9i squared, which is 9. This will always turn positive because this will always be negative, and the I squared will always cancel it. So you could just go 2 times 2 is 4, 3 times 3 is 9, so it's 4 plus 9. That's what we get, 4 plus 9. You can also do the box if you want to get used to it. Or you can just go 2 times 2 is 4, 3 times 3 is 9. And then don't distribute the top because we may be canceling. We'll see. This is 3. This becomes 13. So nothing's going to cancel, so we do want to distribute. So this is 6 plus 9i over 13. And we still want an answer in complex form. So that would be 6 over 13 plus 9/13 I. And there's what we're looking for. So we want that complex number. Here it's not the complex form, here it is. Alright, what if you have I? Well, you could use the conjugate, which is minus 4i. But this is going to introduce a 4 top and bottom. And where am I getting that from? This is 0 plus 4i. So our answer would be 0 minus 4i. Alright, but what we're going to use is we don't want to introduce a 4 top and bottom. We're using the I to get rid of the I. We don't need a conjugate. So what we're going to use instead, we're going to use just I with a minus in front. Just the minus I. And you'll see why right here. So this is 1 minus 3i over 4i. And then we're going to multiply top and bottom by minus I. So we get minus I plus 3i squared. And then on the bottom, we get minus 4i squared. See, all we have to do is turn that into an I squared. Once we turn it into an I squared, just like before, I squareds become real, and we're done. So now on the bottom, we actually have a real number. So it would be minus 1, which makes 4. And then on the top, we have minus I, and then again, that becomes minus 3. So remember, anytime you have an I squared, it becomes negative 1, which makes it into a minus 3. And this becomes negative 1, which makes it into a positive 4. And that's why we put the minus on there, to give us a nice positive value on the denominator. I would work as well. 4i would work as well. Pretty much anything with an I will work. But the minus I would be the cleanest. So we get minus 1/4 I minus 3/4. And then just to switch it around, minus 3/4 minus 1/4 I. And that's our complex number. So if you see a denominator with 2 parts of a complex number, you have the real and the imaginary part, then you want to use a conjugate. If you just have the imaginary part, then just use minus I. You don't have to use the conjugate. So try these two. I have one with just I, and I have one that needs a conjugate. Hit pause, give them a shot. So you should have used 8 plus 5i, And then when we multiply it out, we get 7 times 8 is 56i plus 35i squared. All over, and then on the bottom we just have to multiply. 8 times 8 is 64 plus 5 times 5 is 25. Because we know the middle terms are going to cancel. This is going to be I squared, which cancels the negative. So there we go. And that gives us 56i. And now that would be minus 35 over 89. And then we separate them. Switch them around. And there we go. So just a quick reminder, for the next one, you want to use negative I. So negative I, which would give us negative 4i, and on the bottom, a negative I squared. So it's negative 4i, and that would be negative 1. So it's negative 4i over 1, which is negative 4i. And that's it. So if you just have an imaginary part, use I. If you have a complex part, use the conjugate. And that's it. That's actually not it. This is supposed to be a plus. And there we go. Now that's it.